Great to see you. I can see some of you already saying hi in the comments. Hi, brilliant to see you. So, a couple of weeks ago, I linked you all a previous class on standard form, and I know some of you, hopefully all of you, will have had a little look at that. But it didn't have a lot about calculator methods, and it had a lot of the basic ideas about multiplying numbers with powers as well. So I'm going to go through a few of the most important ideas for GCSE or IGCSE, but also link it to some calculator methods, right? Because I know if you're doing IGCSE in the future, you'll probably be doing a lot of this with calculators, but it still is important to understand what's actually happening. Okay, so first, a little bit of a recap about standard form. So standard form is a format that we can give numbers in that makes it easier to be able to compare between numbers. And it always has a number that's between 1 and something less than 10, so a number like 6, times 10 to the power of something. Okay, that's the format that a lot of mathematicians and scientists use to be able to compare numbers easily without having to count lots and lots of zeros, especially if they're very, very, very big numbers with loads of zeros on the end, or very, very, very tiny numbers like 0.00000005, something like that. Yeah, it can be a pain counting all the zeros, but in standard form, we have a number that we can just look at to know how many times this original number between 1 and less than 10 is times by 10 or divided by 10. Okay, so how big or how small the number is. So we can turn our numbers that are in standard form into numbers in ordinary form, ordinary numbers, by multiplying them, in this case, by 10 two times, because 10 to the power of 2 means 10 times 10. So 6 times 10 to the power of 2, 6 times 10 squared. Do you know what that one's going to be? It's going to be 600, right? 6 times 10 times 10. Okay, then we've got 3.95 times 10 to the power of 6. 10 to the power of 6 is a really good one to learn. 10 to the power of 6 is a million. Okay, so this is going to end up being 3 million and something. So I'm sure you know a lot about how to times and divide by 10 by moving decimal points or moving numbers relative to decimal points. Remember, 3.95 is just like 3.950000, an infinite number of zeros after that. So we need to move the decimal point 6 times in the direction that makes the number bigger. 1, 2, 3, 4, 5, 6. We end up with 3,950,000. Okay. Another important thing to know is when you have something to the power of a negative number, that's like dividing by 10 that many times. Because you might remember, we talked before about how negative powers mean the reciprocal. So 10 to the power of minus 4 is just like 1 over 10 to the power of 4. And if you times a number by 1 over 10 4 times, or 1 over 10 to the power of 4, it's like you've divided by 10 4 times. Okay? So 2 is going to remember, you can use the trick of putting some zeros in front of your 2. The decimal point starts here. We need to divide it by 10 4 times because it's a minus 4. 1, 2, 3, 4. The decimal point's going to end up here. Then we can get rid of any zeros on the front. The important bit is the number of zeros here. So it's going to be 0.0002. And then this last one, 5.2 times 10 to the minus 5. Again, we're dividing by 10 5 times. So again, if it helps you, you could think of some leading zeros here. because all numbers have these zeros. That we just don't write them because it would take too long. We'd be going on forever. So 1, 2, 3, 4, 5. We're going to end up with 0.0000052. And if you prefer one of these movements, so multiplying to dividing or dividing to multiplying, or if you just want to check your answer, which is always a good thing to do, you can always then times by 10 5 times to check your answer. 1, 2, 3, 4, 5, it would become 5.2. So we can check that our answer is correct as an ordinary number. All right, brilliant. Fantastic. We can also turn ordinary numbers into standard form. Remember that number at the beginning always has to be between 1 and less than 10. This is where most people go wrong with standard form. Okay, other than that, in many ways, the converting makes a lot of sense as long as you've got good knowledge of multiplying and dividing by 10, which I think a lot of you will have. So if I wanted to put a decimal point in this number somewhere to turn it into a number that's somewhere between 1 and just less than 10, I'd have to put it here, wouldn't I? So the number at the front is going to be a 3. And now I need to think about, this is quite a big number to start with. So I need to think about how many times I need to times by 10 to get back to where I started. 1, 2, 3, 4. 4 times, right? So 3 times 10 to the power of 4. Same here. Where would the decimal point have to go for this to become a number in between 1 and less than 10? This bit's really super important to get right. It would have to go there. So our number would be 5.129. But we have to also explain how we would get it back to where it started. We'd have to times by 10 3 times. So we write that as 10 to the power of 3. Okay? What about this one? This one's got lots and lots of zeros towards the beginning of it. This is quite a small number. The decimal point would have to be here after the 9 in order for this to be, it would be a whole number, wouldn't it? It would just be 9 in order for it to be a number that's in between 1 and less than 10. So we're going to end up timesing by 10 to the minus something. In other words, dividing by 10 to get it back to where it started. How many times would we need to do that? 1, 2, 3. We'd have to do it 3 times. 9 times 10 to the power of minus 3. And what about this one? This one might be a little bit trickier for some of you. So the decimal point, it always really needs to go after one non-zero digit, you could say. Yeah. So it would end up having to go here in order for it to be a number between 1 and less than 10. Hopefully this is all making sense, and there are some practice questions that you can do at the end. So we're going to end up with 3.84. This started off as a small number, so we're going to have to divide, times 10 to the minus something. Ooh, I'm seeing some really, really good ideas here for answers too. Excellent. We need to divide twice to get back to where we started. So 3.84 times 10 to the power of minus 2. Hey, well done. Really good answers there in the comments. Fantastic. So that is standard form and converting numbers between standard form and ordinary numbers. You'll find that sometimes when you do calculations with your calculator, you'll end up with an answer in standard form if that is easier for the calculator to display, basically. If it's a really tiny number, you might sometimes end up with a number in standard form. And you might have thought, oh, I don't really understand what that means. So now you know. It might look a little bit strange hopefully as you do this, if you practice on your calculator, you'll get an idea of what numbers look like on your calculator in standard form, because some of your answers will come out in standard form. But it's unfortunately quite there doesn't seem to be a way to consistently convert between standard form and ordinary numbers using standard Casio calculators. So you need to be able to do that conversion. However, once you move on to questions like this, you can do the main calculation often using a calculator. There are just a few things that you need to be aware of. So just a reminder for those of you who might want to do this without a calculator, and it's a really good thing to understand as well. If you do this without a calculator, your numbers should really be in ordinary form before you start adding or subtracting, or at least one nice trick you can use is to make sure that the 10 to the power part is the same in both of your numbers. That's fine, because that part tells you, it sort of indirectly tells you the the place value of the 6 and the 2, doesn't it? So in this number, the 6 and the 2 are both in the hundreds column. So we could do 6 take away 2, that's 4. And that gives us our answer. At least that gives us the number of hundreds. So our answer here would be 4 times 10 to the power of 2. So when you're adding or subtracting, if these bits are the same, the 10 to the power parts, they have to be the same, you just add or subtract the numbers at the front. But quite often they're not the same. So you either need to do a little bit of converting with one of them, or maybe just turn them both into ordinary numbers if you're at all unsure. Okay, the only thing with that is you might then, a lot of questions might ask you to give your answer in standard form. So you might need to do a little bit of converting back and forward to get your final answer. Just to show you that this does work, 6 times 10 squared, as I said, this is 600. Well, the 10 squared part we know is 100, right? And 6 times 100, that's 600. And we're taking away 2 times 10 squared. We're taking away 200, and that makes 400, right? So that's 4 times 10 squared. So once you've got the same thing, the same power here of your 10, you can just add or subtract the numbers at the front, and that stays the same. In some ways, think about how this might be similar to fractions. Have a little think about that, because in some ways I feel like there's a connection there. Let's have a go at a few more of these questions. I'm going to start by, no, you know what? I'm going to show you how to do these with a calculator. Okay. Or I'm going to explain to you how to do these with a calculator. One way to do these with a calculator would just be to literally type in 2.5 times and then 10 to the power of 4 to start with, using the 10 button and the power button that looks like this for a lot of you. Or for some of you, it might look like this if you're on the newer calculators, the CW calculators. So it'd be good if you could identify whether you're on an older calculator where it looks like this, if you're using Casio, and the newer CW calculators where it looks like this, because some of the things I'm going to tell you are a little bit different depending on which one. So let's have a go at doing that one first. So I'm going to type in, I'm just going to type in to start with 2.5 times, then I'm going to type 10, then I'm going to press my key here, whichever one I'm using, and then I'm going to put 4 as the power. Yeah? And then add 7.5 times 10, press the power button, 2. And that looks pretty similar to what I've got there on my page. I've got an answer. Did you get an answer as well? The answer I got is here. 25,750. One thing I haven't done there is put the brackets in that I've put on my page here. If you're using this method, especially if you're taking away or dividing, you do need to use the brackets. It's not quite the same when you're, no, it's not, you don't even really need them when you take away, do you? When you're dividing, you definitely do need the brackets. So it can be a good idea to get used to putting them in. But without the brackets, our calculator is going to prioritize the multiplication over the addition anyway, and over the subtraction. So it doesn't really matter in this case whether you use brackets or not. So I'm going to have a go with this next question as well. See if you can do it along with me. So I'm going to type 8 times 10. Then I'm going to press the power button and I'm going to type -1. And it should come up as a superscript number, a tiny number up at the top on all of the Casio calculators from the F8 GT models, I believe. Make sure you move the cursor along so that this minus doesn't end up in the power. So I'm going to type, the minus should end up being quite big in comparison. And then 3 times 10 to the power of -2. And I've got an answer of 0.77 there. And we could have a think about that, couldn't we? So 8 times 10 to the power of -1, that means 8 divided by 10 once, that's 0.8. And then we're taking away 3 times 10 to the power of -2. So that's going to be 3 divided by 10 twice, 0.03. I'm putting an extra 0 in here so I can work this out a little bit more easily. But it's like 80 hundredths, take away 3 hundredths, so 0.77 makes sense. And then, of course, we could turn all of these into standard form. And the questions I've asked at the end will ask you to turn them into standard form. Brilliant. I'm going to show you one more method, and this is going to be slightly different depending on which calculator you use. The great thing about this method is it tells your calculator that you're working in standard form, so you don't need to worry about the brackets in the same way, particularly the brackets for when you're dividing, right? So it's worth thinking about. And actually, on the newer calculator, the one that has this button and says CW, it doesn't really have any downsides. So let me tell you what I'm going to do to use a special standard form button. And the special standard form button is in the middle of the bottom row of all of the calculators that I can see in front of me. I've got a line of several calculators. It's right at the bottom middle, and it either looks like times 10 to the power of x on some of the slightly older calculators, or times 10 and then a square on some of the slightly newer one, the CW one. Okay, so hopefully you can find that. So all I'm going to type in is 3.5. Then I'm going to press that times 10 to the power button, and I'm going to type -4. Ooh, and I've just realised one thing. with the newer calculators, you might need to push your cursor along slightly. So the plus sign ends up being big and in the middle and not as part of a power. Okay, and I'll explain more in a minute. And then I'm going to type 2.04, and then I'm going to press that special 10 times 10 to the power button, and then I'm going to type -3. So right now, just there, I was using the CW calculator, the newest one, that has this kind of button, and this one. So if you identified earlier on that your calculator has the 2 squares for the x to the power, then you're on this newer type of calculator. Hopefully that made sense as we've gone through that. However, if you're on an older calculator, you've got to be really a bit careful with this because it won't show up on the screen like it's meant. Okay, so let me explain. I'm taking an older calculator now, so either the GT Plus or the GTX, and I'm going to type 3.5, then I'm going to press the times 10 to the X button. This is the one I've got this time. It has a times 10 that's quite small, and then I'm going to type -4, and the -4 looks normal sized. It's really strange. So on the older calculators, this is what it looks like on my screen. Times 10, and then it says -4. That's all you need to do though. That is absolutely correct. It just doesn't quite look like you might expect. It doesn't look like a power, but in the newer calculator it does. Okay. And then I'm going to do the same thing again. I've just realized a bonus: if you use the old calculator, you don't have to move the little cursor along. You can just go straight in with the add. 2.04 times, and then I'm going to press the special button, times 10 to the power button, and then I'm going to type -3, and it won't look quite like a power. It'll look kind of like this, but that's okay. Your calculator still knows it should be a power. It is a power. And it doesn't matter which way I do this, I'm going to end up with, if I change my answer to a decimal, oh, you know what? One of my calculators has given me the answer in standard form, and the other one hasn't. There is a way of changing this in the settings, which I could find for you and let you know if you like. But I'm sure you'll be able to convert this back into standard form, right? The decimal point would end up having to go here. So it would be 2.39 times 10. This was quite a small number to start with, and to get it back to where it was, to get it back to where it was, we have to divide. So we're timesing by 10 to the -3. Okay, and that's the answer that my other calculator has given me. So the different calculators might have different factory settings as well. But when it comes to these and how your calculator is giving you the answers, I wouldn't worry too much, because as long as you know how to change between them, which hopefully you do now, that should be fine. You should be able to know what they mean. Okay. Let me know if you've got any questions at all your standard form questions that you might have been coming up with over the last couple of weeks. So once you know that, once you know how your calculator works, you should be able to answer all questions, any questions using your calculator. I'm just going to point out a few more little bits. If you're multiplying in standard form, it is much, much, much easier. A bit like multiplying fractions is much easier, I think, than adding or subtracting them, because you don't have to make sure that this bit is the same, like you don't have to make sure the denominators are the same when you're multiplying fractions. So I'm going to multiply the first numbers together. That's 4 times 6, that's 24. And then I'm going to multiply the 10 to the power parts together. And I can use my knowledge of indices to help me with this. So when you're multiplying, and you have the same base number to any particular power, you add the powers, right? So this is going to give me 10 to the power of 6. So in many ways, I feel that was a little bit easier. Great to know what you think, than some of the adding and subtracting. I was even able to do that with different powers there. However, your answer might not be in standard form already. So make sure, if your question has asked you to give the answer in standard form, make sure you check, this isn't in standard form, is it? Because this number here is too big. In standard form, we'd have 2.4 times 10 to the power of what? Well, we've had to divide this number by 10. That means I need to raise this power by 10 to make the whole number in standard form have the same value. Does that make sense? Any questions about that? So you can use a combination of calculator and your knowledge, perhaps, to make things quicker, however feels best for you. If you're using a calculator, I might decide to type 2.5 times 3.25 into my calculator. That gives me 8.125. And then I could do 10 to the power of minus 2 times 10 to the power of minus 3, which would mean adding together these two powers. Minus 2 plus minus 3, that's going to give me minus 5, right? I just realised this doesn't look very much like an 8. There we go. So it's going to be times 10 to the power of minus 5. Hopefully that makes sense. Be really careful when you're adding and subtracting powers. You've got to take the pluses and minuses carefully into account there. And you know what? I reckon you could have a go at these ones. And there are some practice questions at the end as well. I want to make sure I have time to talk to you a bit about dividing. Now, if you're not using the special key, the times 10 to the power of something key, you must make sure that you put your standard form in brackets. Okay, especially it's really this second one, because if you don't put those brackets in, your calculator won't realize its standard form if you've just typed times 10 to the power of 3. And it will try to do 8 times 10 to the power of 5, then it will divide it by 2, and then it will times by 10 to the power of 3. And that's not really what we want it to do. What we want it to do is to divide these two numbers. 8 divided by 2, that's going to give us 4. And then divide the second part of each number, right? So we're still going to have 4 times 10 to the power of something. 10 to the power of 5 divided by 10 to the power of 3. When we're dividing, we take away the powers. 5 take away 3, that's going to be 2. So 10 to the power of 2. And I believe, I'm pretty sure if you use, I'm going to try it now. If you use the special button, you won't have to worry about that at all. So I'm going to press 8, and then I'm going to use the times 10 to the power button. Give me a shout if you're not sure what I mean, and I will explain it again. Then I'm going to press divide 2 times, and then my special 10 to the power button, and then I'm going to press 3. Ooh. On this calculator, this isn't working. So it would be a good idea to use brackets anyway. I think on some of the calculators that might work, and on others it might not. Yes. So do use your brackets for dividing. If you want, you can always put the brackets in with standard form. It might make it easier to remember. But when you're dividing, it really won't work if you don't have those brackets in place. So I'm ending up with an answer of 400, which is 4 times 10 to the power of 2. I'm going to double check that with all the calculators later. I'm gonna have a fun afternoon. Um, and I'll put a comment to let you know what I found. I'm sure I found earlier a calculator where that did work. Ah, let's do one more together. Let's do this next one together before we finish. I thought this might be a shorter class today, but I've ended up doing so much talking. My apologies. Hopefully it's been useful. So we're going to divide, and remember you could, if you wanted to, you could divide these with your calculator if you needed to. So I could do 3 divided by 1.5, or you might know that that's 2. So that's the number that goes at the front. And then we've got 10 to the power of minus 5 divided by 10 to the power of minus 3. Ooh, so when you're dividing, you take away the powers. So we're going to have minus 5 take away minus 3. So this is the only time you do any funny negative become positive kind of rules. When you're adding and subtracting, that's when the signs are right next to each other. So this is the same as minus 5 add 3, and then we need to think carefully about what that is. It's like we're starting on minus 5 on the number line and we're adding 3. We're moving closer to 0, but we don't quite get there. So we always leave the times 10 in, and it's going to be times 10 to the minus 2. Fantastic. And have a go at doing those with your calculator as well. Make sure you're happy that your answers are correct. And let me know if you have any questions. Amazing. So a little bit of standard form practice there, some adding and subtracting with standard form, and make sure you're confident with how to do this on your calculators. Even if you're doing a GCSE rather than international GCSE, 2 of the papers are calculator papers. So it's well worth knowing these little calculator tricks and the little quirks, the things that can go a little bit wrong with your calculator ahead of time. So start practicing that all now. Well done, everyone. I look forward to seeing you all very soon. Ooh, and I can see a really good comment there. If you have a Casio CW calculator, you have to put brackets in. Ooh, excellent. Thank you for checking that out for me. Brilliant. So I think the consensus is use brackets when you're dividing with standard form, just to make sure your calculator knows what it's doing. Fantastic. See you all very soon. Have a lovely day. Bye.